Good morning, everyone. My name is Nadita Ramachala. I'm the manager of the Standardization Division, and we'd like to thank everyone for joining us for this technical workshop on database languages. Would like to
Trinidad and Tobago Bureau of Standards. Your safety and well-being is our top priority. Please allow us a few minutes of your time to go through the emergency procedures for the compound. We ask that you pay close attention to the information that is being imparted, since it can significantly improve your chances of evacuating the building safely if the need arises. Should the alarm sound, or, if so, advised by your host, you are to exit the room in a brisk but orderly manner using the closest safe exit point. On exiting the room, continue out of the building by following the directional exit signs posted and make your way to the muster point. Our muster point is located outside the compound in front of the main guard booth. Whilst at the muster point, remain in your group and await further instructions. Should you require medical attention or discover that one of your colleagues is missing, raise an alarm and assistance would be provided. Do not re-enter the building unless you are advised to do so. Thank you for your time and enjoy your stay at the Bureau.
Thank you. And next on the agenda, we have our national anthem. So I invite everyone to stand for the national anthem. Have your seats. We would like to start today's proceedings with welcome remarks from the Executive Director of TTBS, Mr. Jose Trejo. Mr. Trejo is a Belizean national with over 22 years of public service experience, including his role as an economist at the Central Bank of Belize. He has worked with various government ministries in Belize, including natural resources, trade, finance, and agriculture. From 2015 to 2017, he served as chairman of the CARICOM Regional Organization for Standards and Quality and the Central American CAMET Group. He was the director of the Belize Bureau of Standards from 2007 to 2023. TTBS. I now invite Mr. Trejo to deliver opening remarks.
Thank you, Nadita. Good morning, everyone. Distinguished guests, colleagues, and friends. It is my honor to welcome you to today's technical workshop on database languages, hosted by the Trinidad and Tobago Bureau of Standards. We're truly delighted to have you all with us as we come together to engage in discussions that will shape the future of data management and the role of database languages, particularly SQL and the newly finalized GQL standard. This workshop is an important occasion for us to delve deeper into these technological advancements and reflect on the critical role that international standards play in driving innovation, nurturing collaboration, and creating opportunities for growth in our local and global communities. We're at a pivotal moment in the world of technology and data management, and this workshop is a key part of our ongoing effort to ensure that Trinidad and Tobago remains connected to these global trends to support the national digital transformation journey. TTBS, as the national standards body, is proud to be at the forefront of this initiative, actively participating in global standardization efforts through our involvement in the ISO IEC Joint Technical Committee 1, JTC 1. Not to mention, digital transformation is a key focus in TTBS's strategy for 2024 to 2029. The ISO IEC Joint Technical Committee, established in 1987, I was about 5 or 6 years old, develops international IT standards to promote interoperability, global collaboration, and market access. A key part of this work is being done by Subcommittee 32, Working Group 3, which focuses on database languages like SQL and the newer GQL for property graph databases. In 2023, Working Group 3 updated the SQL standard, and in 2024, they finalized the GQL standard. These updates are crucial for effective data management, querying, and sharing in today's interconnected digital world. Since 2023, Mr. Joshua Bulu, our Technical Secretary for the National Technical Committee for ICT, has represented Trinidad and Tobago in these global discussions. We have actively contributed to the development and adoption of 5 key standards, and just recently, 2 of these standards were updated, demonstrating our continued commitment to remaining at the forefront of global standardization efforts. Our contributions to the development of standards such as SQL and GQL are a testament to our commitment to promoting global interoperability and ensuring that our local industries and institutions are aligned with the best practices in data management. As we gather today, we are reminded of the immense power that international standards hold in shaping our future. From enhancing data interoperability to fostering economic growth and digital transformation, these standards are essential to building a robust and resilient infrastructure for the digital economy. They support our national development goals while simultaneously achieving the government's broader vision for a digital society that is secure, competitive, and future-ready. Today's workshop will provide us with the opportunity to deepen our understanding of how these standards will impact the way we work with data and technology. It is also a chance for us to share insights, exchange knowledge, and build the partnerships that will propel us forward in this exciting journey. In closing, I want to emphasize that this workshop is just one of many opportunities for us to come together, collaborate, and work towards building a stronger, more resilient, and more competitive digital economy. Let us use today's discussions to deepen our knowledge and strengthen our relationships and find innovative solutions to the challenges ahead. Once again, thank you all for being here today. I look forward to the productive discussions and collaborations that lie ahead. Thank you.
Thank you, Mr. Trejo, for delivering the welcome remarks. We will now turn to remarks from the chairman of the TTBS's Board of Directors, Mr. Lawford Dupree. Mr. Dupree is a chemical engineer with 44 years of experience in the energy sector. He is the current chairman of the TTBS's board and served as the executive director of TTBS, also the president and managing director of the former Petrotrin, as well as the chairman of the National Petroleum Marketing Company. Mr. Dupree also serves on several boards in the private sector with his training and skills in chemical and general engineering technology, business development, human resource development, project management, marketing, corporate planning, and governance. Mr. Dupree brings his wide business experience and his extensive knowledge of an interest in standards development and enforcement to the board. So I now invite Mr. Dupree to deliver his remarks.
Good morning, everybody. Good morning. I think Jose has basically outlined why we're happy to have you here. And I think you know why you're here. So I'm just going to say that I'm especially happy to have with us today some international experts. From Germany, we have Mr. John Bartels, Mr. Stephen, is it Cannon? Mr. Stephen Cannon from the Netherlands, Mr. Keith Hare, and Mr. Jim Melton from the United States of America. So we're very pleased to have them among us today, and I'm sure they're going to share some of their thoughts and ideas with those of you who are capable of receiving those thoughts and ideas. For myself, I am quite advanced in age. My first contact with languages, computer languages, was back to 1963, when they were teaching Fortran at the time to engineers. And I can remember vividly when the professor told the class that he was going to be, they had to do this course in Fortran. There was a sigh of shock that went through the class. What is that, you know? As a matter of fact, I think 99% of the class failed the first exam. I had to repeat it because they just couldn't conceive that they would ever have to use that in their lives, in their working lives. And at that time, the only computer around was a big room at the university. Took up about, I don't know, 20 or 30 square feet. It was a big one. But we never got to use it anyway. You have to, if you remember how those things, you guys would probably know how that works. Yeah. So today's workshop, we're going to explore the critical advancements in structured query and graph query languages. And by the way, I just want to say also that my son is well into this computer stuff, you know. So I told him I was going to give a little talk today. We had a meeting about QSL languages. He said, QSL, what was that? I said, you look it up, you know. So he went on the computer trying to find QSL. He couldn't find anything. He said, Dad, you sure you got it right? I said, let me check. So then I checked again as SQL. So that's how we go. So our involvement in ISO, IEC initiatives, particularly through our participation in the JTC1, speak of the commitment through this engagement, and this has strengthened our ties with ISO and fostered collaboration with stakeholders here at home. We can see tangible benefits such as knowledge sharing, capacity building, and expanded networking opportunities. In particular, the dialogue taking place today will offer insights that will strengthen the capacity of our local businesses, government ministries, regulators, and academic institutions in the field of data management and technology. It's important that we recognize that these standards help to build a quality infrastructure, and they directly support the government of Trinidad and Tobago's vision for digital transportation. By aligning our efforts with the ISO global standards, we will enable businesses to adapt to emerging technologies and help to ensure that the plans for creating a digital economy in Trinidad and Tobago are realized as quickly and efficiently as possible. So this event today is another important milestone in TTBS's role as a leader in the international standardization community. It allows us to showcase our expertise and commitment to national development strategies as we continue to align our work with the national quality policy, our own strategic plan for 2024 to 2029, and the TTBS's national standardization strategy, which is currently being reviewed with the Ministry of Trade and Industry. Today's gathering with its esteemed audience of people from the government, regulatory agencies, private sector, financial institutions, and of course, our visitors. It's testament to the broad recognition of the importance of standards across all sectors. And we are proud to offer this platform where we can bring key national and international experts to engage in discussions that will guide our collective path forward. And here I must acknowledge the hard work and the dedication that has brought us to this point. I take this opportunity also to announce that 3 critical national standards for ICT have been declared by the Trinidad and Tobago Board of Directors as follows. TTS ISO IEC 27001-2024, which deals with information security, cybersecurity, privacy protection, information security management systems. This standard is a global standard for securing data and preventing costly data breaches. We also have the TTS ISO IEC 27002, again dealing with information security, cybersecurity, and privacy protection information security controls. And this standard presents a collection of best practices for information security controls, which companies can use to take a proactive approach to cybersecurity and risk assessment. We have also TTS ISO 42001-2024, Information Technology, Artificial Intelligence Management Systems. And this is the first international standard for AI, which can help organizations manage AI systems responsibly and ethically. In today's session, therefore, let us embrace this opportunity to enhance our understanding of databases languages. I'm certainly going to learn something about it, which will have a lasting impact on the future of our nation's ICT landscape and the digital transformation objectives. I want to say that last week I was lucky to listen to an interview. Those of you will know who I'm talking about, Andy Johnson. He interviewed the Minister of Digital Transformation, which I hadn't known his name before, Mr. Hassel Bacchus. And how many of you know the minister's name? Okay, well, there's some. Anyway, that's good. We're making progress. He impressed me. I was very impressed with his command of the whole subject. And he was able to give a very good account of himself. So I felt very good that we had a minister that seemed to be in charge of what he was supposed to be doing. So I hope you get a chance to meet him at some point in time, but I can assure you that if you do, you'll be impressed with his knowledge of the subject. So that is it. Thank you for being here, and I look forward to hearing the results of your discussions as you go forward today. Thank you very much.
Thank you, Mr. Dupree. We would now excuse Mr. Dupree and Mr. Trejo and our board members in the audience as they have a very important board meeting now. And we would invite our photographer, Mr. Yehudi Walters, to take a photo of the head table. I would now invite the board members to come up for a photo as well. As well as our international experts. We will now move into the technical workshop component, and we have the first presentation from Joshua Budu. He's a standards officer responsible for the ICT portfolio, and he serves as the technical secretary for the National Technical Committee for ICT. He has over 5 years' experience in the IT industry and has a bachelor's degree in electrical and computer engineering. He's also currently pursuing his MSc in ICT, specializing in machine learning. So I invite Joshua to deliver a presentation.
Okay, good morning, everyone. My name is Joshua Budu, as Nadita would have mentioned. I'm a standards officer attached to the standardization division here at the TTBS. And before we dive into today's discussion, I would just like to give a brief overview of JTC1, which is the Joint Technical Committee 1, and also some of the recent highlights in today's national ICT standards. So we'll start off with what exactly is JTC1? Okay. So JTC1 is also known as Joint Technical Committee 1, and it was established in 1987 as a collaboration between two key international bodies, one being the ISO, the International Organization for Standardization, and the IEC, known as the International Electrotechnical Commission. Now, JTC1 was created to provide a single comprehensive standardization committee in which to address international information technology standardization. Now, the scope of JTC1 is short and simple, as we can see on the screen. It is simply standardization in the field of information technology. And today, the work of JTC1 influences nearly every aspect of our digital infrastructure. And to see exactly how, we'd first take a look at the organizational structure of JTC1. So on the screen, we could see that JTC1 operates through a hierarchical system of subcommittees, or SCs, and working groups, or WGs. Now, at the top level, JTC1 itself oversees the broad scope of ICT standardization. However, given the complexity and the diversity of ICT topics, JTC1 is divided into multiple subcommittees, or SCs, and each focus on a specific area of ICT. So each subcommittee could be further divided into working groups, or WGs, that develop, refine, and maintain specific standards under their area of expertise. So now that we've discussed how JTC1 is structured, we take a look at some of the subcommittees on the JTC1, just so we have an idea of what that looks like. So this is going to be very small on the screen, but as we could see from the image, there are many subcommittees on the JTC1, ranging from at the top, which you probably can't see, SC2, which is titled Coded Character Sets, all the way down to SC44, which is titled Consumer Protection in the Field of Privacy by Design. Now, in the middle of all of these subcommittees, we have SC32 in the red rectangle, titled Data Management and Interchange, and this plays a crucial role in defining how data is structured, exchanged, and governed across different systems. Now, within SC32, we have 4 working groups, one of which is Working Group 3, or WG3, which is titled Database Language. And later in today's proceedings, my colleagues from Working Group 3 will dive deeper into database language itself. So now we take a moment to understand just the scale of the standardization efforts of JTC1. And as you can see from the screen, ISO has published 3,574 standards across various industries. But of those standards, 537 standards fall under the direct responsibility of JTC1. And additionally, of the 536 ISO standards that are currently in development, 32 of these standards are being directly handled by JTC1. Now, I'd like to briefly touch on some of the standards developed by JTC1 that has been adopted nationally. But before I do so, I'd like to thank and also bring to the attention of everyone the committee responsible for the national review of any nationally adopted standards developed by JTC1. And this is the National Technical Committee for ICT, who have been tasked with assisting and advising us here at the TTBS in the formulation of national standards related to ICT. The committee is chaired by Dr. Rochelle Adams from the Department of Electrical and Computer Engineering at the University of the West Indies, and she's here in the audience today. And as we could see on the screen, the committee comprises of a diverse background of organizations from government ministries to academia, as well as private organizations and entities. So now that we've covered the role of the NTC in reviewing these international standards, we take a look at some of the key JTC1 standards that TTBS has nationally adopted. Mr. Dupree would have mentioned some of these previously, but over the years, TTBS has worked to ensure that our ICT standards align with global best practices. And this has led to the adoption and the updating of several of the key standards that we see on the screen. So in 2018 to 2020, we adopted ISO IEC 17788 and 17789. And these define the core concepts and the reference architecture for cloud computing, ensuring a common understanding for providers and users of cloud computing. In that same period, we also adopted ISO IEC 27001, 27002, and 27003. And these form the foundation of information security management. And this covers risk management, security controls, and guidance and implementation. Now, at that time, between 2018 to 2020, some of these national adoptions were based on the then current versions of the base ISO documents. And since then, some of these standards would have been superseded by new ISO-based documents. And due to this, in 2024, we updated ISO IEC 27001 and 27002 to their latest base versions, incorporating new security controls such as architectures. And additionally, we also introduced ISO IEC 42001, which Mr. Dupree also mentioned, which is the first global standard for AI, ethical AI development. And this helps to ensure that AI systems are transparent, accountable, and secure. Now, before I wrap up, these latest national adoptions from 2024 will be available soon on our website at gottbs.com. So this brings me to the end of my brief overview of JTC and our nationally adopted ICT standards. Thanks.
Thanks, Joshua, and I should say, if you have an interest in participating in our standardization activities, you can reach out to me or Joshua, because we have a vibrant group of experts locally working on some of the standards that JTC1 has produced already and looking at the national adoptions. So we'll now go into the more technical discussions on the database languages. And we have Mr. Keith here and Bjorn Bartels, Database Administration and Data Replication. Since 2005, Keith has served as the convener/chair of ISO IEC JTC1 SC32 Working Group 3. Just remember, Working Group covers database languages, the International Standards Committee responsible for the SQL and GQL database language standards. He's also the vice chair of INCITS Data Management, the US Mirror Committee of SC32. And the presentation will be a joint one. So then we have Bjorn Bartels. He's representing Germany. So at Oracle Germany, he's responsible for high performance database tuning, SQL. He's a SQL language specialist, database architect of the national delegation from Germany. So that is coordinated by DIN in Germany to JTC1. He's also the editor of ISO IEC JTC1 9075 SQL standard, and he's an expert on SC32 Working Group 3. So I'm sure that after this session, you will know all the technical details about SQL and GQL. And we are also pleased to have our other international experts. We feel privileged to host them in Trinidad and Tobago to showcase the work that we have been doing locally and the contributions that have been made by Trinidad and Tobago in the JTC1. So we look forward to other useful meetings, very technical discussions over the rest of this week. And further than that, we will be continuing our contributions to JTC1 through TTBS. So if you have an interest in contributing to the development of international standards in this area, please let us know. We are happy to have experts participate in the international process. So I now invite Keith and Johan for their presentation. So Johan will start us off.
Yeah, I am Jörn Bartels, and the first thing is I have to thank for the invitation from TTBS that we could have our meeting for this week here in this nice place and this impressive building. At least here, this room is really impressive. I think it is ages ago that I did a presentation in such an auditorium, what we have here. Okay. That was more or less all said already, what is on this slide. I only may add a little bit to that. I did my master's in computer science in 84. And since then, I'm in the database industry. I started with Oracle and I'm still with Oracle. So over 40 years of Oracle experience and of course also SQL and relational database experience. Yeah, I started 20 years ago as I was well known in Oracle Germany that I'm interested in all the strange aspects of SQL, so that I was volunteered to join DIN and join these international working group meetings and provide my knowledge about especially usage of SQL in the field. That means with customers, as my normal work is to work with customers and how they use SQL and what limitations they see and what we can do in the standardization group. Yeah, Keith will come to that slide maybe, or he doesn't need the slide. He knows what's on that slide. Okay. We heard already a little bit what is the first part of the presentation from my previous speakers, especially Joshua. What is the standards, what the SQL and GQL standards are. Then we will a little go deeper and explain the GQL, the SQL, PGQ, and SQL standards. The middle one, the SQL, PGQ, is the bridge between the two standards. So we try to make these two standards in a way consistent that when you know one standard, you can use part of that in this intermediate standard. I will, Keith will explain a little bit more what that does. And then the question is, of course, who uses the SQL standards? I hope all of you heard the word SQL already. And the standard, of course, is not for public consumption, more or less. It is a highly technical document. When I started in the industry in 84, I think the first version of the SQL standard came out, which was 80 pages or something like that. And these days, we have 4,500 pages. So this is a big thing to maintain and also really hard to read. For that reason, we did a series of guide standards, which are more on the explanatory side. You heard that the standard we are dealing with is 9075. So we invented 19075, which has guides on various aspects of the SQL language. And then I go for the future of SQL and GQL a little bit, what we plan to do in the next years. Okay, what is a standard? Yeah, it is more or less that a couple of people sit together and say, yeah, that's the way we want to do it. And everybody adheres to that decision. So the stuff they do together, it is possible to do together because they understand exactly each other, what they mean. And computer languages are, of course, a case of that. It means having 5 people speaking different computer languages makes no sense. as you would have need 5 different compilers, maybe even 5 different computers. So computer languages need to be standardized. In the very, very early days of computing, the vendors of computers which sold them had their own computing languages, which were called assembler at that time. So they were really tailored for machines. Of course, you couldn't take one program and put it on another computer and run it on that computer. Then the real computing languages came up, like COBOL as the first one, which was more or less the start of standardization of computing languages. Then a plethora of more computing languages came up. And it was, I think, in the late 70s that a database language showed up, which was called SQL already at that time, but it was SEQEL, I think. But that showed up as a used term already. So these days we have SQL as the language for relational databases. Okay, so the international standards help really to get the most use for users as they can run their programs on different computers, different database systems. It has real value for vendors as they can attract a larger community of users, as some of you may have been taught at university what SQL is. So it is easy for companies to find people which know that language and can work with the language. Yeah, that is stuff what Joshua already explained, what international standard organizations are. The big ones are ISO, IEC, ITU. And the members of these standard organizations are country organizations like TTBS, or in my case, DIN in Germany, or in the US, it's ANSI. And we have from all over the world these standard organizations which collaborate. And if it really comes to the point that you need to decide what should be in the standard, it's the countries which vote more or less. And it is not a normal voting like you know from an election that who has the majority wins. No, this type of collaboration is in a level that you need to agree on something. So everybody also can support it then when it is agreed and written down and published. But there are also other standard creating organizations, which is private organizations. Relatively well known is W3C, the World Wide Web Consortium, which does most of the web standards, like your HTTPS, what you use as a URI in your browser. The language behind that is defined by W3C. Then interesting are IETF and IEEE, which is also private standards. Then, which are even less official, it's OASIS and ECMA, for example. They provide also standards, and most of the standards, the important ones they publish, are also published under the name of ISO, as they then give their standards to ISO to get them published also as ISO standards. Okay, so standards have benefit for businesses, consumers, and regulators. For business, it's clear, easy, and cheaper to cooperate and compete. And it's also, they have the larger customer base when they do standard-based products. For consumers, increased choices. For SQL databases, you may have 10 different databases on the market. You can select which one you want to have, which one suits your needs better, and so on. And you find in the market to hire people which know that already. So it is less educational needed to find people which can do the task you want to have done. And for regulators, it is easy that they don't have to put technical information into laws or regulations. They can just reference a standard. So the EU does that quite often, that they reference standards in the EU regulations. They even give an order out to the standardization organizations. We need a standard on that and that topic. And so the technical experts come together and develop the standard. And the nice thing is these standards are not developed by politicians. These are developed by technical people, so they know what they do. Okay, before I go to this example, just a couple of words about the SQL standard. I think majority of the business data of the world is stored in SQL databases. So the SQL standard is quite important for world businesses. It is not so well known, the importance of that standard. A better known example are containers. Everybody knows how important containers are for world business. So we use the example of containers to show the values of standards. The container is simple. It is just the size, which is defined, how much weight they can carry. And the result is reduce labor to load and unload ships, reduce the cost of shipping goods worldwide. I think without containers, we wouldn't have all this stuff from China in our shops. You can transport them with ships, trucks, and trains. And I grew up in Hamburg, actually, which is a harbor city. And when I was really young, that was the time before containers. And I really remember the queues of people which had to cross the River Elbe to go to the places where the ships land to unload and load these ships. These days, it's all fully automated. It is ways and ways cheaper these days as it was 60 years ago or whatever, when the containers came into the picture. Another famous standard is here built into this laptop, which is wireless networks, for example. This is an IEEE standard. It is not an ISO IEC JTC1 standard. So there are different standard organizations which have different benefits and drawbacks. So it is not always also a clear decision where a standard is developed. It is quite depending on the companies which share an interest in a standard, where they go for to develop that standard. And here you see the complete series of the wireless network standards. And I think this one has the BE standard already built in. So everybody uses more or less this standard. And now we come to the database language standards. It is 9075 for SQL. And I think 4 years ago, we started the development of a new variant of a database standard. The databases are different. We aim with these languages. SQL aims for relational databases, and GQL aims for graph languages. And they need, of course, a different language. And our working group 3 is quite famous for to make that stuff it does interoperable, so that you can use both standards more or less together. Keith will explain later on what the role of PGQ in that part is, that you can more or less run a query over relational data and graph data at the same time. Here we see the picture Josh showed us already, just reduced to what is important for us. We are the one on the bottom, so end of the food chain. And we meet about 3 times a year and have that are face-to-face meetings. and have about the same number of online meetings always in between. Before COVID hit, we had normally only face-to-face meetings, and then we had to switch within a couple of days over to only online meetings. And now we come to a compromise that we do half of the meetings face-to-face and half online. And we try to keep the online meetings as effective as possible. That means as soon as a real discussion starts on an online meeting, we just move that topic over to the next face-to-face meeting, because it's much better to do real discussions when you can look each other into your faces. This is a slide which shows a little bit what different levels a standard can have. When we have the idea for a standard, we start a new work item proposal. This is more or less a worldwide decision of all national bodies of JTC1. Oh, is this an interesting topic we should go for? And by the way, do you have people which are interested to work on that topic? And we need some minimum requirements and agreement worldwide that a new topic will be worked on. Then for a long time, there will be working drafts. That means they are just within the working group and shows the progress of the work. Then we have a committee draft. That is the first one we show to the public after we were asked to do the standard. And this one asks just for comments. That means we show it to all the national bodies, and the people in the national bodies, which are IT oriented, can comment on that standard. Oh, this is not that nice. That is not that nice. That are not good comments. Better ones are, this is not nice and this is better. So after we went through committee drafts, we go to draft international standards. That is one level higher again, because there you can say already, yeah, with the exception of these couple of topics, we like that standard. It means we like the progressing to the next level. And you can have the DIS 1 time, 2 times, depending what quality your draft had already. And when you have resolved all the issues, you go to the level of final draft international standard, which is FDIS. And there, the national bodies are only allowed to correct spelling errors. Maybe the wording is not absolutely correct and stuff like that. And they say yes or no. When you get a no at that level, you start at the beginning. Okay, and the last level is then, of course, an international standard. And last year we had the SQL standard became again an international standard. We have every 5 years approximately a new revision of our standards just to incorporate new stuff. And at the end of the presentation today, you will see what we plan then for the next revision, which should be out 27 for the SQL standard. Yeah, this shows a little bit what I explained previously on the list. What are the decision points in a standard development? And as I said, oh, FDIS has no yes and no. FDIS always goes through, which is nice. But there are feedback loops on the complete process so that we can improve the quality of the standard as much as possible. But on the other side, we find these days still errors we did in the standard, which we did 20 years ago. So with 2,400 or 4,500 pages, they are not without errors. Yeah. The first standard which came out for relational data for SQL databases was in '87. What I said, it was a paper of 80 pages or something like that. It had barely the select, update, delete in it, and that's it. Then we came out in '89, which has had referential integrity, which is that you can define primary keys, foreign keys, and the actions you may have on foreign key violations and stuff like that. In 92, we got internationalization that we have the standard based on ISO JTC 1. In 99, we added user-defined types and database triggers so that you can have also an active database which does stuff automatically when it is needed. In 2003, we integrated the first time another language into SQL, which is XQuery. So you are able to store XML data within a relational database, and you can query it either via SQL or XQuery. So we have a dual view at that time already on the data, and you can use or write also queries which combine XQuery and SQL in one query. In 2008, we expanded the XML implementation to have full functionality. And yes, some people may know it is hard to update views in SQL. And for that purpose, when it is too hard to decide which tables to update in which way, we had instead off triggers invented, which make it possible that you write your own code for the update of these views. In 2011, we got some temporal extensions so that you could record transaction dates and valid dates. For example, a person moves and the address record needs to have a valid date from to, and so you can add that as not standard columns to the table, but as specialized columns which exactly explain what the valid dates are. In 2016, we added a third language, which is JSON. So we are now able also to store JSON data in a SQL database, or let's say relational database. We can query it with SQL, we can query it with JSON, and now we can write queries which have JSON, XQuery, and SQL in one query. Then we did some other extensions to the language and added also new functionality that we can have multi-dimensional arrays. And a typical thing is pictures, that you can store pictures in the database, you can crop the pictures, you can change the format of the pictures, all within the database. And you know, a picture is a couple of megabytes big. So in the past, you had to read the couple of megabytes from the database into your application, process the stuff what you were doing, and write it back. Now, with that extension, you can do all that within the database, and you don't have to move the data. Yeah, and then 2 years ago, we had the property graphs in SQL. We had JSON enhancements. So JSON became a real data type that you can have a column which stores a JSON document. Whenever we do something significant new, we create a new part of the SQL Standards series. You see here already quite a lot of parts we have. Oh, that is nice. Part one is framework, which explains more or less how the standard is built and the rules we use within the standard. Foundation is, yeah, that is what all of you know what a SQL database is. It has the basic SQL functionality in Foundation. Of course, you need also to access the database. And the easiest one in the beginning was a core level interface like ODBC, which you could use to access the database. Then the question was, oh, should we not have also some procedural language? Because SQL is a set-oriented language, and there are some stuff which needs to be done in a procedural way. So the persistent stored modules came around, which are routines, functions, which are stored in the database. And again, the benefit is These are directly executed within the database engine, so the data does not need to be moved. Then we thought, oh, the world is not just our databases, the world is also other data. So we did a management for external data. We added that you can have also files as part of your queries, and you just define how to access these files, what is the format, and stuff like that. With part 10, we got the object language bindings. It means it is more or less object extensions that you can define types, subtypes, supertypes, use these types as the base of tables, and it is the integration of the relational model with an object-oriented model. Part 11, that is a part which is more or less needed also for part 2, which is the information and definition schemas. You know, all databases have dictionaries and this is a standardized version of these dictionaries the databases have. With part 13, we got an integration with Java so that you can also write Java programs which access the database. With part 14 are the XML related specifications. That is where XQuery came into the picture. Part 15 are the multidimensional arrays. And the new part 16, which Keith will explain, is the property graph queries that you can do property graph queries within an SQL environment. Yes, SQL 2023 is the latest revision of our SQL standard. Includes the new part of expanded the support for JSON is now a full-fledged data type. We do, of course, always additions, means, well, there's a loop, a hole, there's a small piece of functionality missing. We add that, especially when we get the response from actual users. And I'm supporting in Germany one of the biggest software houses of Germany. And of course, I get a lot of feedback from them, what functionality they would like to see. And of course, bug fixes and cleanup is everywhere. And now I'd like to hand over to my colleague Keith, doing the GQL part and PGQ part.
All right, you heard a little bit about me, but I'm a database geek. I've spent a lot of my career looking at databases and figuring out how to make them database applications for clients, figuring out how to make them more robust and faster. I've sometimes described my job as figuring out obscure things. I've also, for a number of years, had a contract working with a property graph database company called Neo4j, where my task with Neo4j has been to work on developing the property graph database language standard GQL and to work with them on their internal strategy for GQL. So what is GQL? Well, from the part that Jorn talked about, you can see that over the years, our approach to SQL has been to incorporate new technology into SQL. Our tendency has been, we see a new technology, we think about how it can be done in SQL. So in the 1990s, object-oriented languages were going to replace SQL. We incorporated them. In the early 2000s, XML was going to replace SQL. We incorporated it, and so on. About seven and a half years ago, we started looking closely at property graphs. And I'll come back to exactly what I mean by a property graph in a moment. And became convinced that there was probably a room in SQL for some property graph capability, but there was also enough industry demand to create a new language and standard specifically for property graphs. And I'll talk a little more about that. in a bit. Basically, we did a lot of work before we proposed the project. The project was officially approved in September of 2019. We did a little bit of work and then published the first version of the standard last year. The slide says April 12th. It also depended a little bit on where you were in the world. I actually noticed the publication notice on the ISO website about 9 p.m. my time on April 11th. Not that I was focusing on it. But it's a full database language standard, and I'll give you a high-level view. One of the things I should warn you is that in this committee, it's easy to get us to talk about the work we do. The hard part is getting us to stop. All right, so a lot of people have worked with SQL over the years. You're dealing with relational data and tables and constraints. You have data manipulation, you have transactions and things. One of the complications in SQL is that if you're building a query that's accessing multiple tables, you have to specify the relationship between those tables actually in the query, in the join clause. And for those of us that have done consulting on applications, that's where we find a lot of errors, where people don't get the join clauses correct. With GQL, one of the big differences, it's a different way of thinking about the data, but one of the big differences is that you can actually store the relationship as data. Now you have to do that, but once you have the relationship stored as data, then you can actually write queries where you don't know what the relationship is. And that has some very interesting capabilities. Both languages are non-procedural. What that means is you tell the database what to do, and the database figures out how to do it. Which means that the query you write focuses on the data, on the knowledge of the data, and not on all of the underlying data structures. You can always hire consultants to figure out the underlying data structures and make it fast. So what is a property graph? The basic idea is that you have what are called nodes, sometimes called vertices, and relationships, which are sometimes called edges. And you could almost think of a node as a table, and they're sort of similar, but they have some differences. But the edge is actually data stored in the database that maps a relationship, in this case, for example, between a city node and a person node. And property graph databases are often represented as visually as graphs, because that's the way you think about the data. So you think of it as nodes and connections between the nodes. And the nodes can be directed or undirected, and they can have labels and properties and so on. But a node or an edge has a unique identity somehow. And so that's the high level view of property graphs. In the 15, 20 years ago, there was a lot of work in what people called NoSQL databases. What really happened was that there were limitations, sometimes in SQL, sometimes only in particular implementations. And so people came up with ways to work around those databases. And that led to a whole variety of databases that were not going to include SQL. Over time, one of the things that happened was that if you needed a query language to do dynamic queries, that you started writing something, and by the time you got through writing the language, it looked a lot like SQL. And so the NoSQL got sort of changed to mean not only SQL. Property graph databases came out of that and are, to my mind, the most significant development that has come out of the NoSQL world. Because it's a different way of thinking and focuses on representing not only the data, but the relationships between the data and giving you the power to query it. However, there's a lot of data in the world that is in SQL databases. So I say I have a byte of data, which is 10 to the 27th bytes. I think it's a fun word. You know, I could have a brontobyte of data about brontosauruses and so on. But the point is there's a lot of data. And you can't necessarily take a huge amount of data and reload it into a property graph database. But there's a lot of benefit of some of the property graph queries. And so in parallel, while we were building the GQL standard, we also built the PGQ standard that Gordon mentioned. The idea of the SQL PGQ standard is that you build a property graph view on top of existing SQL tables. And then you can write property graph queries in an SQL from clause. So it brings the power of property graph queries to the existing SQL data. There's been discussion in various forums over the years of why would you bother to have a property graph standard separate when you could have just done PGQ? And the answer to that is, in part, the 4,500 pages of the SQL standard. Starting from scratch to build a database that adheres to the SQL standard is a lot of work and a lot of overhead. And there are actually data structures and access paths that the property graph databases are using that are different, that are optimized specifically for property graphs. So I believe there is room in the world for both property graph queries in SQL and a separate property graph database. But if you have a lot of data, you don't want to have to reload it. So that's where PGQ comes in. How do you represent this? Or how do you think about it? Well, you've got this sort of square tabular thing that's SQL. And you've got the GQL nodes and edges. And the common part is what we've come to call graph pattern matching. So we have in PGQ property graph queries on top of SQL tables. GQL is a full database language, but we have built the standards so that the graph pattern matching queries that you use in SQL PGQ are identical to the graph pattern matching queries that you use in SQL. So if you learn how to do property graph queries in GQL, you can do property graph queries in SQL PGQ, and the other way around. If you learn how to use property graph queries in PGQ, then you can do it in GQL. So there is enough overlap that the knowledge that you learn in one area will translate to another area. Quick example, I can actually talk for an hour or better on just the languages itself, and I'm not going to do that today. So in SQL PGQ, I might have created a graph of view called students graph, and then I would say select stuff from the graph table where the parameters are students graph, and then the graph pattern matching query that looks like a match statement where we're basically presenting a pattern of the relationships. In GQL, I would say, hey, use students graph, which is going to be a GQL property graph, and the match statement is exactly the same in the two languages. that's actually one of the achievements of the standards process that I'm extremely proud of. I didn't do a lot of the work on the graph pattern matching query, but basically we had experts from the relational database products and experts from the property graph database products that worked together and came to a common understanding of how to do this. A couple of presentations, I gave copies of these to Joshua, and he can distribute them to you. But in last fall, we did a couple of presentations when we were in Baku, Azerbaijan, and these are details of the different languages. And at this meeting, I have a copy of a presentation that I've put together of GQL for SQL users, because people have been using SQL for years, don't necessarily understand GQL yet. If they hang around me long enough, they will. All right, so we do some really obscure technical stuff. How do we do it? Jorn mentioned that we have 2 or 3 meetings a year, because of various travel restrictions that people have, we've started doing them with remote access. So at this meeting, we've only had 4 people. For various reasons, we've only had 4 people in person. On our meetings this week, we've had another 10 or 12 people at various times on the web conference. So we're an international group of national body standards, but participants operate as individual experts. Within our group, we've been doing this a while, and we've developed, I think, a very good environment where we can disagree on the technical issues during the meeting and still go out and have dinner together. That's one of the real advantages of meeting in person, is that you have the extra time to go talk to each other, to learn about each other's children or grandchildren or dogs or whatever, and build the personal relationships. And that's actually, okay. I really enjoy standards. I think it's a lot of fun. It's possible I have a strange sense of fun, but part of it is the interpersonal relationships between the participants. But basically the way we work is we write papers. A couple of people have sat through our presentations this week and can tell you that we sometimes go through 50-page papers with detailed explanations about why you want to do it, and then the detailed explanations of what it is we're going to change in the standard. And we find that by having everything written out in detail, we've got a better chance of discussing and getting it right. And the papers come from various participants around the world. For the GQL standard, I think the number of papers that went into it was about 420, 430 papers. And it's actually a little higher than that for various reasons, but it took a lot of work. WG3 makes the final decisions. We, when we say a standard is ready to go, we put it out through the various hierarchies for votes and comments and things. And it takes a while. When we were in Sanya, China last summer, they had snails. And so I added a picture of a snail to this picture because it's not always the fastest. We've had a few meetings. We used to only do web conferences in 2020, or so we used to only do in-person meetings. In 2020, all of a sudden, in-person meetings went out of style. And so we had to figure out how to transform and get work done in web conferences. Our committee has participants from Japan, Korea, China, Europe, the UK, the US, and occasionally other things. So finding a good time, a time that's good for everybody for a web conference is impossible. And so in 2021, what we worked out is that every meeting we shift by 8 hours. What our committee is actually really good at is figuring out how to get things done no matter what the rules are. And so I ran meetings at midnight my time. Other people participated at midnight their time, but we got work done. In 2025, we're meeting here in Trinidad. We're not actually in the Port of Spain, I understand, but that's the closest I had when I wrote the slide. We have a meeting in Sydney, end of September. I think we're going to Barcelona. We probably will have another web conference this year. Our mode of operation for in-person meetings has been that we go to interesting places and sit in conference rooms. And I have pictures to prove it. So this was last March in Barbados, Sonia, China in June, Baku, Azerbaijan in September. We had windows in that, which we don't always have, and our meeting in Trinidad this week. So we go to interesting places, we sit in conference rooms and stare at our computer screens. Jorn mentioned a bit, but one of the things to think about is who actually uses the SQL and GQL standards. There are standards that are process standards, and so end users can adopt the process standard directly. In the case of computer language standards, the primary groups that are actually going to use the standard directly are going to be the database vendors, because they're going to build products that adhere to the standard more or less. There are other open source projects. There's an organization called the Link Data Benchmark Council that is doing some work on implementing GQL. There's the academic researchers, but the people that actually use the database products are using products that implement the SQL or GQL standard. So if you're using a database product, you're probably not going to go get our standard and read it. If you are, please join the committee. But it will affect what you do and how you do it. And one of the things that means is that we have to think not in terms of this year, but in terms of 5 years and 10 years down the road. What is happening now? How is that going to affect things? What can we do in the language to support new capabilities? So the standards process, it's iterative, it's collaborative. We work together. We have compromises between vendors, between philosophies, between technologies, and there's a little bit of bureaucracy in the process. It can be a bit tedious, but I think the results are actually pretty good. And I suspect most of you sitting here have used an SQL database at one point or another from various things, and that is in part because the SQL standard is a standard, and people have become convinced that it is worth implementing. So what are we going to do next? And Jorn wanted to do this part because we're doing some cool stuff.
Okay. Yeah, every new edition has additional functionality, and there's a buzzword in the world these days, which is called artificial intelligence. Everybody wants to do artificial intelligence. And what is the base of artificial intelligence? It's vectors. That means you have some models which you learn and create these models. And with these models, you put some input data in and you get a vector out which describes the input data you used. What to do with these vectors? Of course, they need to be stored somewhere. So we are back to the topic of databases. That means the base of all AI functionality is, of course, to store the AI information somewhere. And that was for us, of course, the reason that we added on the process of adding a new data type to the data to the SQL language, which is called a vector. It is just one-dimensional, and this vector is a little bit strange compared to normal vectors. Because with normal vectors, you can say, oh, what is on the 25th element of this vector? This type of vectors is different because this vector makes only sense as the complete content of one vector, because that describes exactly one other thing, and the AI engines which do the learning and conversion do not tell you, oh, on the 6th element of the vector, we have stored that and that information. So the vector is more or less only a single thing which has just for human consumption a structure of elements. You have in the beginning unstructured data, text, photos, sound, whatever, and you generate the vector embeddings with some external function or service. You could use OpenAI for that, or Google has services which can create these vector embeddings. And then you need to store the data. And these days, we are already one step further as ChatGPT is. ChatGPT works just on vectors. But a photo has, of course, an information like, who is the photographer? Where is that? So there is metadata with all these elements you create vector embeddings on. A document, who's the author? From whom to whom was this document sent? All that is, of course, sometimes interested based database. We designed the queries we can do on vectors in a way that you can have normal structured queries, structured query part, which says, oh, I want to have this type of whatever it is. And then please give me the ones which match my information I want to have on the unstructured part the best in this set of the data. So our vectors now, we have started with adding vectors to SQL and GQL. And what I like to say here is we like to see people which have interest in that field. Either it's academia or companies which like to add their knowledge and their opinions to our work to join our group. So we have an invitation for tomorrow. Whoever is interested to see how we operate, he may come to our meeting tomorrow and see how our working works and decide for himself, oh yeah, I might be interested to do something there. And as Keith already said, we have hybrid meetings always. So this time we are in Trinidad, so it's easy for you to join in person. And there are also people, I think, on the web which are on the Zoom call. They can also join on the meetings on Zoom calls when the traveling is too expensive, takes too much time or whatever. So all that is possible. So we can also invite for tomorrow if people want to join our Zoom conference, which we have open for over the whole day. And just contact Nadita in case you are interested to do something like that. Just that was a side remark there. Okay, our vectors have, of course, a value for the vector, a type of the vector values. So these elements might be integer 16, integer 32, or some strange data type this vectorization provides. And we have, of course, dimensions. This means how many aspects of an object the engine uses, and as more aspects you have, you can much better select which is as the one alike the one you looking at, and we store the vector either as SQL fields. That means we have just on the create table now an additional data type. You create a table XYZ with column ABC vector, and you have the vector data in the database. In GQL, it's the same thing. You have properties and nodes and edges. Here we see the example. In the middle of the create table statement, we just have the vector data type, which has 128 elements, and each element is an element of type float 32. And we have a vector of a photo, which has the same sizes. We can insert, however this vector is stored. The structure of the vector is more or less used for insert and select, so that we can these vectors in and out of the database to have a communication format which is already established. And we can insert and select them. But of course, it's not so useful to select the vectors out of the database. We like to process the vectors within the database. And for that purpose, we have a couple of functions which allow to work directly with the vectors within the database. The major functionality is, of course, vector distance. That means I like to have all vectors which are very close to a vector I give the system. Example is these pictures of a house. I would like to have houses which look alike this house. That means they have a very short distance from this point. There are different methods to calculate the distance, which is Euclidean, Euclidean squared, Manhattan, cosine, dot, and Hamming algorithms. And that are the ones we have so far defined, but we are absolutely open if there's a need for additional ones to extend our definition there. Yeah, there you see a query that we want to have an author and article text ordered by the distance from an article text we provide. That means they should be alike. So in the future, it will be hard to do some copy and paste in your thesis or something like that, as everybody can easily find out which articles what was already published with that same content. Yeah, we have not included in the database the creation of the vectors, as that is a highly specialized process. And there are so many different vectorization functions that we cannot do that directly in the database. But we store the database, the vector, we query the data, the vector, and what we have also is specialized indexes. You know, from the normal relational SQL database, it is an exact business. If I want to have all sales which were done in Trinidad, I get the sales which were done in Trinidad. Nothing else, and all of them. With vector distance indexes, it's a little bit different because they use optimization technologies which have not an exact result. They try to be as close as possible to the exact result, but it's not always exact. So it's the first time that we have to deal within the SQL database with not really exact results. You know, when you ask an AI system, sometimes you get rubbish back. It happens. Then we have, of course, additional vector operators where we can create a vector. We can find out what the dimension of the vector is. We can normalize, measure the distance against the zero vector. and we can serialize the vector so that we can move it from one system to another system as character data. Yeah, we see that the vector data types and operations are important enough to get a new edition of SQL and GQL out. The current target is that we want to go out in 27. That means within this year, we need to start the first round of CD consultations to see what other national bodies think about this. Okay, that was the current latest and hottest we do with the SQL and GQL standards. And as AI is a hot topic, we hope that people get interest in what we are doing and see, hopefully, one or two or even more of you being interested in the work we do. When you are from a university, we of course invite also your advanced students to take participation if they can do something. We had 8 years ago a student which did his PhD thesis on a complete topic of extension of this SQL standard. So we are really open for collaboration there, also with the academia. Yeah, you saw already the 9 editions since 1987 of the SQL standard. The GQL standard is brand new, but we will have already in 2 years the next edition. As for GQL, of course, we pushed some stuff out of the 24 edition. We just had not the time to do it. And so it will come in, but also the vector data type is really important for the GQL standard, as the combination of these two capabilities is really interesting. Yeah, and then we had a nice early breakfast yesterday in a street food place. And we had doubles there, so we tried also some local food already. And the point is, do you have any questions? And I think all 4 of us are more than happy to answer them. If anybody has a question, there's a microphone going around in the room. And if you like to know something.
Good morning.
Yeah.
Thanks so much for that brilliant presentation. Are there any current vendors who implemented the GQL standard as yet?
2 vendors who have published conformance statements for GQL, Neo4j and a month and a half, 2 months ago, a product called Altipa, ULT IPA, I think. There are a number of other vendors that have parts of it. Google Spanner recently released a version, and they do parts of SQL PGQ and parts of GQL. Oracle has, in Oracle 23, has released SQL PGQ implementation. There's work in the Postgres community on PGQ. So it's coming. It's a little slower than I would like, but it's coming.
Thanks. That's it. That's it. Thank you so much. Yeah, I would investigate.
More questions?
So my question is with regards to I believe it's the SQL, I might not be saying it correctly, but the link between SQL and the GQL. How, to me, it seems like there's a layer or some sort of a way where you can use your GQL queries with your existing SQL databases. That's correct, right? I think it's PGQ.
Right.
Okay. So I'm an application developer. So I would use, for example, for REST APIs, there is GraphQL where, yeah, so is that similar to the, because with GraphQL, I'm using .NET, so I can use a package, and something like Hot Chocolate is a package available. You can use that, and I can query my backend databases using GraphQL as a different form of a API instead of your traditional REST API.
Yeah, GraphQL, as you said, is an API, so it's more of a, it basically is a call interface rather than a database language. So what would happen with both PGQ and with GQL is that vendors would write interfaces or transport layers that GraphQL can use. And so it's more middleware than actually the underlying database.
So something like a proxy.
It's sort of, the problem with GraphQL is it's not really a query language and it's not really graph. It's a way of building a call level interface that is sort of graphish.
Okay, so with GQL, it's actually
GQL is the underlying data. If you got into the GQL standard a lot, one of the missing pieces you would discover is that we haven't written a standard that explains how you would interface GQL to a programming language. One of the issues is when SQL was created, there was COBOL, there was Fortran, there was Pascal, there was Ada. The environment where people are doing property graphs now includes languages like Python and Rust, and someplace I have a list of about 20 different languages that people are using. And so we haven't yet figured out how to describe in a standard way the interface, but GraphQL would be one way to build an interface.
okay. One more question, and again, with my background in .NET, I know you all are database professionals, so you may not use ORMs. I would use Entity Framework a lot in my development. With the GQL, I know we're still working on it. Database vendors are coming out with their solutions. Is there any ORM that would work with GQL?
That's more in the tools part of the various database vendors than things that we're actually working on directly. Neo4j, for example, I know has interfaces for various tools and programming languages. Microsoft has a project that I know of but don't know any of the details of, where they are building a new property graph database. And my assumption will be that they will have .NET interfaces to that, but I don't know that for sure yet.
Okay, no problem. Thanks.
I really enjoy the vector capabilities that the standard is bringing in, and I think it would be very helpful for the AI thing, community. But what about the blockchain community? Here is a community that whereby you have there's a need, for example, to store triggers for oracles, to store smart contracts. There's a need for all of these types of things. What you developing any standards in this direction?
Yeah, that was a hobby of me 10 years ago that I started to do some work on blockchain. And it came more or less out that the database vendors, which pay our salary, of course, were not that interested. But on the other side, there is some blockchain work going on. I know it from my employer, Oracle, that they have blockchain functionality integrated to the database. And what is a blockchain, more or less? It's a way to guarantee that you can't change any the transactions you did in the past. And that is the thing what blockchain is. It is not a big thing. It is a question how it is done.
Um, there's a lot of storage aspects to, for example, smart contracts. There's a need to trigger those smart contracts. There's a need for a mechanism. Right now, you have to pay a lot of money for oracles to do it. Meaning, it would be a nice way for us to to deal with that.
Yeah, the only thing I know is currently with an Oracle that we invented unchangeable tables. That means which is the backbone of a blockchain, like we have with the vector data type for the AI community. And to build stuff on top of that, I have not seen any interest in the database industry to do these automatic execution of contracts and whatever you can define in a blockchain. Our level is more the technology level that makes it possible to store information, which is then protected by blockchain mechanisms.
Thanks.
Just making a comment on this gentleman's post that blockchain is not a database. It is a ledger. It is a mutable ledger. That's all. You cannot.
On top of the blockchain. That is the question.
So you could argue that yes, you can store the data for the ledger in a database, right? But plenty of people, I have spent many years on this as part of the internet society and dealing with similar conversations, and people tend to confuse or conflate one interchangeably with the other, and that's not the case. The main strength with databases and so on is asset compliance and being able to roll back changes and so on, versus having a immutable ledger. And that is the main fact that we had a client so recently, and they decided to go all blockchain, and then they realized, but wait, we can't roll back. I call it buzzword bingo. Everybody likes to have, there's blockchain, now it's AI. It's next year going to be something else, and while, certain aspects of the technology like vectors and so on, integrating that in the database, I can definitely see the plus of that, especially was like a few clients who were started using AI in like medical record processing and so on, and putting those data into the database and having a query at the database level will definitely remove a few those abstraction layers from the middleware and getting you closer to bare metal so you can get better performance. I think it's a case of storing and recalling and so on. You stick that into the ledger, but you can store the data in terms of the information. But that smart contract being done at the database level. It's two slightly different things, and it's not necessarily I wouldn't see it as part of like a SQL standard, because at the end of the data, smart contract is just that. It's just data. Execute X on condition Y. Yeah.
I've seen a smart contract is a lot more than data.
Yes.
But you see, for example, like I find PLSQL very, very useful because it's at the database. And in a similar fashion, if you can get smart contracts at the database,
yes,
that's where that was what I wanted the contribution to be. So for example, I had a process that was running in the middleware, using middleware Python, that was taking 3 hours, put it in the database. It took less than a second, it took less than a minute. So that's how fast it is. So
Yeah, I know PL SQL. I'm not only a SQL specialist. I know also PL SQL quite well.
So just to add on to your question, ISO actually has a committee specialized in blockchain. It's TC307. It's titled Blockchain and Distributed Ledger Technologies. So if you're interested, you could always look into that technical committee as well.
And we have a liaison with them so that whenever it comes to storage technologies over there, we are in the boat with them. Any more questions?
Identify yourself, name and organization, so that we have a record of the questions that are coming in, and we could follow up on, for example, the blockchain issue directly with the persons.
Hello, testing. I'm Gian Bell, Telesystems Limited. Just had a general question. You're saying in probably around 2027, you might be having a new edition of SQL.
Yes.
You're saying to kind of expand on vector storage and AI.
Yes.
Right, is that correct? Is there anything that you can kind of expand upon what the considerations are, et cetera, in that regard? Just asking.
Yeah, what I said, it is just the vector data type and the supporting functions for vectors, what we are including in the database to enable queries which span the AI capabilities of vectors, like that we can calculate distances between some vectors and the relational data in one query. That is the target we have always, to make data available which comes from different sources, which have different formats, which have different philosophies behind them, so that we can have them in one query. That is more or less the content, what we add for AI support, the base technology to store AI information.
Thank you very much.
So I did not introduce myself. My name is Deshaun Ellis from LSL Limited. We are a software development company. What I have is not a question, but it's a realization. So I would have started to use databases in 2012. So I would have been introduced to SQL Server using Microsoft's solution. I would have used different, I would use Oracle when I was in school as well. And I did not realize, based on one of the slides you had, you stated that you went through the different standards throughout the years. SQL 89 with referential integrity, 92 with internationalization, 99 with triggers and user-defined functions. I was very impressed because I thought that these things were just always in databases, and it's incredible that you all worked in databases with all these things. I can't imagine working without a trigger, for example. Yeah, so really good work, and yeah, I am impressed, and I hope we continue to develop these standards in the future.
Yeah, but databases have versions, and each version gets a new functionality, and database standards have editions, and each edition gets a new functionality in it. So when I started at Oracle in '84, and I started even before that at university, so the first version of Oracle I saw was version 3 actually, and now we are at 23. So we needed to do something in between.
and this slide is my attempt to summarize things in one slide. So this is no way everything that went into these various versions. It's everything I can remember when I wrote the slide.
Okay, looks like there are no more questions. No.
So this is more a comment. I do have an associate who could not be here today because he's on another project. He would have probably been very interested in joining the technical committee work. I started back in '96, so you know my first touch with Oracle was probably 8i, which I mean was 1999. You know, probably aged myself a little bit there, but so I remember the pre 2000s is what it was like, you know. So but I've since delegated such tasks to people younger and fresher brains than myself. So I will definitely follow up and pass the information along. Also, I'm a member of the Internet Society, so I would like to pass this along as well to some of our more technically inclined members who would definitely be interested in potentially joining, or at least if remotely contributing.
Yeah, we are well known that we don't have that many users in our group. And we are more or less a group of database vendors. There are 2 users actually here in the room in the group, and I think that's only 2 we have. And you see their interest is that they even come over to Trinidad here to really work on the standard. We would like to have a lot more user participation there. And now with our hybrid meetings, it's much easier for users to participate in the work of WG3. But you have, of course, to do that via TTBS because they have to authorize you. Tomorrow is an exception because we can always invite guests. But if you want to do regular work, you have to go via TTBS. And I think they are more than happy to authorize you to work with the group.
Yes, I would like to recognize Dr. Shell Adams, the chair of our National Technical Committee for ICT. So we would have started on some of the standards related to information security, cybersecurity, and AI. And given the interest level that we have seen here, we would probably invite stakeholders to participate on the committee, but specifically looking at the database languages. So anyone who's interested can reach out to myself or Joshua, and the participation has to be coordinated through the TTBS, as Johan was saying. So it is not open just for anyone to join an ISO meeting, but TTBS is responsible for coordinating participation and the national inputs into international standardization. And we do that by forming a technical committee similar to the one we have for ICT. And experts can then participate at the national level, but they can also participate as experts to help in the development of the international standards as well. So given the government's trust for digital transformation, it is one of the areas that TTBS itself has prioritized in a strategic plan and supporting the diversification efforts, because in order to have the digital transformation initiatives, it is based on having the relevant standards, especially the international standards, to ensure that our products are able to compete globally. And also, I would like to invite any of the online participants. I think right now we have 22 participants. If there are any questions, or they can be raised in the chat or by raising hands. So I invite the online participants, if you have any questions, to let us know, because we'll be seeking to close off the session in a few minutes. Yes, I think there was one more question from.
I'm Wayne Goodrich. I'm from the University of West Indies. one of the things I was wondering is the thought process that, that you use when you're developing standards, because to me, you also have to provide the solution at the same time. Because for example, like when you look at vectors, how vectors, what type of algorithms would be used, you have to be thinking about it not only from a goal perspective, but also you have to be a vendor at the same time. So I want you to describe what really goes on there.
Well, for example, in the case of vectors, the initial proposal for the vectors in SQL was largely written by the participants from the US from a company called Oracle. And so we've had some discussion about some of the syntax, but it looks like part of what Oracle did when they added vectors to their products was to look at what else was going on in the industry.
I see the trick. So really what happens then is the vendors that push this.
Right,
particular
but
standard.
they have to convince everybody else. And we've had a lot of discussion in the committee, first starting last summer in Sonia, China, where we discussed the technology, how it was going to be used. There's still the possibility that some of like the vector distance function name of the routines will change. But you know, I can give you the vector paper that we wrote to add vectors to the GQL language. And among other things, I've got a comparison in that paper of the different distance functions that are used in the different products. I will tell you that looking at vectors in various products, one of the places that I found documentation not completely as well as it should would be on the distance for similarity functions. So in the standard, we are trying to explicitly say that what the distance functions return is relative, and the larger the number of the distance functions return, the farther the relative distance. And that's a piece that I found really annoyingly missing in the documentation. But the vector capabilities are in the standard are originally driven by Oracle, but similar to what other vendors are doing. The vector paper this week was adding vectors to GQL. That was influenced by the property graph people, influenced by the capabilities in SQL. And there are compromises. There are places where when we were working on the GQL version, we found errors in what had been proposed for SQL, and so have fixed those. So vendors tend to drive things in part because they can invest in the time to write the papers. But the graph pattern matching language in SQL, PGQ, and GQL was a compromise and collaboration between Oracle, between Neo4j, between TigerGraph, and various other vendors in the various industries. And so yesterday we had a presentation from a guy by the name of Fred Zemke on adding support for cheapest path in both SQL, PGQ, and GQL. And that is the result of about 2 years.
I have some user which and look, oh, is this useful really for me, for my needs? Because a vendor tries to make it useful for the users because they want to sell their stuff. But on the other side, it is we like participation of users. And Stephen, the guy who got just the microphone, is a long time user and he can explain his own experience there.
Yeah, one of the things that I noticed in the time I've been established the organization, back in the early days, the vendors used to compete. They would come in with their own proposals to try and get their specific functionality into the standard to disadvantage the other ones. Over the years, that has significantly changed. Now what you see is that the vendor will come up with an idea and then he cooperates with the other vendors in the same area to come up with something which they can agree on, because that enlarges the market and gives everybody a win rather than things. And I think it's also worth mentioning that in the graphs thing, we also had some input from the academics who've done some validation of what's being proposed to say, does that really work? Are there some edge cases which have errors and that sort of thing? So it's very much more a collaborative effort. And although, as Keith and Jon said, it comes initially from the vendors, because if nobody's going to implement it, it's never going to happen. The role of the users and the academics is to make sure that what comes out at the other end is usable and understandable. And vendors can sometimes take the shortcut and not look at exactly what the poor programmer is going to have to write. Is that going to be understandable, and so on. So there's a role in the review process for the users, even though the driving force comes out of the implementations. And for me, one of the annoying things in the past was the temporal aspects. I worked for the Dutch tax office implementing a system which actually had two timelines in it, a transaction timeline and a valid timeline, because they wanted to know not only what had happened, but when they knew about it, so had they put the right tax in it. We had to invent that ourselves. And the vendors at that stage were saying, nobody's interested in temporal, we're not interested. No, there's no call for it. Fortunately, later on, we did actually get temporal in, but about 5 or 6 years too late, in my opinion, because there was a need for it. I've never implemented a system which did not have temporal aspects in it, and I suspect that nobody else has either. But vendors sometimes have a market driven by their salespeople who don't necessarily understand what the person on the computer keyboard is actually facing. So there is I think there's a role, and I think we would be very grateful if we could get some academics and end users who've got real needs in there, if only just to monitor what we're doing. They don't have to come up with the change proposals. We have a system in our standards. We have a thing at the end, which is editor's notes, which contains language opportunities, things which people have said, this would be a good idea, but I haven't got a proposal for you yet. And we record it. We got another one called possible problems. Somebody says, I don't think that's right. So we record it. And every time we go out for one of these consultations or ballots, those language opportunities, those possible problems are explicitly addressed by the committee, and they have to come up with a resolution. Like, oh, we can't do that opportunity now. That's a problem. We need to fix it. That wasn't really a problem, but we understand that it looked like it. Maybe we had to change the wording to make it clearer or something like that. So even that aspect, there is a role for non-vendors to say, that's not right, that I don't understand. That would be nice, even though I can't myself write the proposal. So yeah, there is a role for everybody here, not just for the people with the big money.
I'm John. I wanted to add a little perspective to this idea of vendors versus users. In the early days of development of SQL, the user community was much better represented, and they actually drove some really important capabilities. So for example, the referential integrity that you guys heard mentioned a little earlier, published in SQL 89, was very controversial with the vendors. The vendors did not want to do full referential integrity because they were afraid of the performance implications. But big user communities like the telephone systems would have to track every single connection among tens of millions in a single city. They desperately needed good referential integrity, and the users stood up for themselves. They browbeat the vendors, and they wrote the change proposals. So even if you come from a user community side or from technology averse industries, you still have the opportunity to make a real difference in how these standards get developed. So by all means, if you feel that you can contribute even to requirements for future versions of relational database language or graph database language, you can have a place in the community and help us build the right system.
Yeah, one other example is to go via the user groups of the databases. We have a person from Postgres in the team to do for WG3, and he is the contact person of his company into the user groups. So he gets all the information what user groups demand, what they would like to have. And an example, what we are currently discussing, is a foreign key join. Means you know how joins look like. And I saw so many examples in my career that people forgot columns in a join to specify them. And what do? Oh, I put a distinct on it, so the result is correct in the at least. And he got the demand from his user groups that there should be a foreign key join. That means a join is only allowed if there is a foreign key defined which covers exactly that join condition, so that developers can do less errors, and it is also easier for somebody who has to read code 5 years later or something like that. Oh yeah, that is that foreign key is following there. And you cannot join a length with a weight or something like that. That is not possible with that. That came out of the user group of Postgres. So user groups are also a source where you can, via user groups, you can put things in. You push as a user group the vendor, or even members of the user group participate in the standardization process, and then more or less you are able to push stuff into the standard. And what Stephen already said, it is a collaboration normally between vendors and our group, and we like to have functionality which is supported or is planned to be supported by a vendor to implement that in the standard. It is always a question, who should be first? If the vendors are first, they have maybe already developed their language or whatever, how this extension could be used. And if there are two vendors first, there might be different. If we are first, there might be no vendor who wants to implement that. So it has to be on the same speed, more or less. And it is also good for the quality of the standard, because we are, when these groups are participating in the standardization process, they have access to all the intermediate documents. And of course, they use the documents as the blueprint, how it should be implemented. And if we wrote some rubbish in there, they will find it because they are dependent on the quality of that. And so we get a lot of error corrections from implementers which actually try to implement our standards. Another interesting source where we get error correction from is from translation. The SQL standard is actually translated into Japanese. And the translators for the Japanese standard are part of our group. And of course, they go through each and any line in the standard, and they know what the line means because they are from our group. And of course, whenever they do a new translation, how many errors do we get? 50, 100, something like that. Maybe also old errors they have not captured in the last round, but you're getting better. So yeah, we like to invite you to participate in the standardization process as much as you can. The entry barriers are not that high anymore since we have hybrid meetings. It is more or less time you are investing. And the learn curve is really high when you want to start to read standards. I still have not mastered every area of the standard, and I'm since 20 years with the standards community now. And you can, I started with the information and definition schema because that's pure SQL and relatively easy to understand. And so I go step by step forward to understand how stuff works.
All right, are there any other questions? Thank you very much for your time.
Thank you, Kate and Ewan. So before I close off, I would like to ask our AV provider to put on the QR code. We have a customer feedback form. So you can scan and complete, and for the online participants, we'll place the link in the chat. Okay, so I will move to the closing remarks. So good morning, everyone, again. As we bring today's insightful and I have to say exciting workshop to a close, I would like to take a moment to reflect on the significance of what we have accomplished together. Over the past few hours, we have had the privilege of deepening our understanding of the advancements in database languages, particularly SQL and the newly finalized GPL standard. These discussions have highlighted the importance of international collaboration and the role of standards in shaping the future of data management. The workshop would not have been possible without the invaluable contributions of many individuals and organizations. First and foremost, I'd like to extend deepest gratitude to our esteemed presenters, Mr. Keith here and Mr. Ewan Bartels, for sharing their expertise and providing us with a global perspective on the developments in WG3's work. Your insights and information provided have been truly enlightening. Special thanks to Mr. Stephen Cannon and Mr. Jim Melton for sharing their expertise as well with us. A sincere thanks to the speakers who went before, Mr. Jose Trio, our Executive Director of TTBS, as well as Mr. Lofa Dupre, the Chairman of the TTBS Board. To our participants, we thank you so much for joining, whether from the public or private sector, academia or regulatory bodies. Your engagement and the questions have been very insightful. We really appreciate your presence today. Also, I'd like to thank the team at TTBS. So I'm from the standardization division. So thanks to the standardization team, as well as our supporting units, procurement, marketing, printry, accounts, and maintenance for their assistance in organizing this event. And to our international colleagues and the wider IEC JTC 1 SC 32 Working Group 3 team, we appreciate the ability to contribute to the international standards development process. And we appreciate the time that you all took to have this technical workshop with us. It has been really enlightening for me. I mean, I know a lot more about SQL and GQL. So it is really something that has helped the national community bring the international process closer to us in Trinidad and Tobago. So we really appreciate that. So as we conclude, we'd like to take the time to thank you all again and for strengthening the collaborations between all different stakeholders to strengthen our digital infrastructure and